Yes, sir.
Right. So I have posted some numericals on the our WhatsApp group. So there are cantilever truss are there. Okay, cantilever truss where one in this your fixed others or it is free. That is cantilever beam. Like cantilever beam, it is a cantilever truss. So today we will take the cantilever truss and we will finish the truss today. From Monday we will take the frames. So now we will take this cantilever truss. As one student has asked me yesterday that why we are not taking the fixed support for the roof trusses. Okay, so as we are solving the determinant trusses, and if you take the fixed support, okay, then it will be indeterminate trusses. So we will use that particular, but the number of unknowns will increase, and for that we will use the additional equations. As we are using the summation fx, summation fy, summation of m, that is equation for finding out the support reaction or finding out the forces in the member. But there is a fixed support is also there, but we require additional method to solve that particular truss. Okay, असं काही नाही की फिक्स सपोर्ट नसतो अशातला भाग नाहीये. Okay, if you see this truss, you can see this truss. So this is your completely fixed support at one end. It is fixed in the wall. This truss is fixed in the wall, that is fixed support at this end, that is E and D. But but we are starting from free end always in cantilever truss. In cantilever truss, always we have to start from the free end. Free end. So we get all the forces in the member that is starting from this free end, that is from joint A. So remember in cantilever truss, always start from the free end. Okay, so that you get the forces in the member. असं नाही की फिक्स सपोर्ट नसतो अशातला भाग नाहीये. Okay, so now we'll take this numerical. So click on the new project, Truss. So today is your 28. So meter, kilonewton, truss. Next. Okay. So I will go to the triangular truss. Okay, we'll see that whether it is available in structure wizard. So we'll choose structure wizard. Open structure wizard. Finish. Please check whether it is available or not. So this is the lattice truss. So first of all, we'll change the unit meter. So length. So 6 meter and 3 meter. 6 meter is the span length and 3 meter is the height, right? Six meter, height is 3 meter, width is 0. Number of bays along the length is 2. Apply. So same truss is here. Okay. We'll see whether we will get the same truss. Yes, we got the same truss. So file, merge with Staad Pro, yes, okay. So we get this truss. So we can go to the structure wizard also. Click on the lattice girder. Then span or the length is 6 meter, height is your 3 meter. That is the case, right? And we got the same truss geometry here, as you can see. Okay. So now next part. Is it understood, all of you? Any difficulty, please ask. स्ट्रक्चर विजार्ड कळालं का? परत एकदा सांगू? Yes, please. Is it understood or whether I should repeat once again? Structure wizard. Yes, please. Huh?
Understood, sir.
Yeah. Okay. Thank you. So this is the truss. Directly go to the structure wizard. Click on the required model. Then put the length and the height, and width is 0 because along the z-axis, will not taking any dimensions or any member along the z-axis that is perpendicular to your screen. That is z-axis. So it is two-dimensional structure, right? Then general, click on material. So which material I will assign? Stainless steel or aluminum? Yes, please. For true roof truss, as I told in last lecture also. Yes, concrete or aluminum or stainless steel or steel. Yes, please. I'm waiting for your reply. So steel is up to the truss. Always use the steel material for the roof trusses. Okay, so I assign the steel. So then I will go to the property. So most important is here that check it is in the numerical, that is cross section is given. We have to find out the vertical deflection at joint E, that is at 3N. So see that all the horizontal and vertical member, having area is 1000 mm square, and inclined member having area is 1500 mm square. All the horizontal and vertical member having area is 1000 mm square and inclined member is 1500. So we'll assign the property. So where should I go? Define section database, material thickness or ISO table. Where should I click? Yes, please.
Section database.
Section database. Okay, correct. So section database. So which country I will choose? European, French, German, Japanese, etc. Yes, please.
Indian.
Then which type of section? I section, T section,
Angle
channel,
section.
angle. Yes, please.
Angles.
Angle, yes. So now what I will do, I will go to the view table. So I have to select the section having area is equal to how much centimeter square? 1000 mm square is nothing but how much centimeter square? Yes, please. 10, na? Is it okay?
Yes.
Right. So you can see on the screen, ISA 55 by 55 by 10, having area is exactly 10 centimeters square. I will select this section. I will select add. Then next is having 1500. Area is having 15 centimeters square. So I have to select the section in a such way that having area is equal to or near about the 15 centimeters square. So it is 15.10. So I will select this, add, close. So this section is provided to the all horizontal and vertical members. So press the control button and select all the members. Press control button and select all the members. Assign to selected beams, assign. And for incline members, it is ISA 80 by 80 by 10, that is 1500 mm square area, right? So material is assigned, properties are also assigned, right? Now we will go to the support. Now if you see in the diagram, this is your at top, there is a showing as a hinge support, and at the bottom you can see the roller support. Okay, hinge and roller support. So the support, create, fill, add, create, fix butt, add. So this will assign to this joint. And This will assign to this joint. Close. So now next load is there. So at this top end 100 kilonewton load and bottom it is a 50 kilonewton load. 50 and 100. So load case detail, add. Point load, add, close. Then we have to apply the point load 150, add, and minus 50, add, close. So there are 100 kilonewton and 50 kilonewton is applied. So 100 kilonewton is applied at this end. And 50 kilonewton load is applied here. 100 kilonewton and 50 kilonewton. Okay. Is it understood, all of you?
Yes, sir.
Okay. One minute. One minute. 1 minute. Okay, so I have changed the support as you can see. So till now we will what we are doing, that is what support is your, you can see in this diagram, support is your now incline horizontal. Support is your horizontal or incline, right? So now till then what we are saying taking, that is Fy is released because support is vertical. Now roller support is inclined, so horizontal reaction is there. Okay, and at the top support, I'm audible. Is it I am audible?
Yes, sir.
राईट. आता इथे बघा हा हिंज सपोर्ट, आतापर्यंत आपण काय करत होतो, इथे बघा या डायग्राम मध्ये इथे हिंज सपोर्ट असा आहे, वर्टिकल आहे आणि हा पण वर्टिकल आहे. इथे एफ वाय रिलीज करत होतो. येस ऑर नो? बरोबर ना? वी आर रिलीजिंग एफ वाय. येस ऑर नो?
Yes, sir.
Right. Now it is, now for this case at support A ला vertical reaction Fy आणि horizontal Fx. आता इथे काय होईल नेक्स्ट केस मध्ये, इथे horizontal reaction म्हणजे Fy येईल आणि vertical reaction म्हणजे Fx येईल. फॉर सपोर्ट A, at support A ला हिंज सपोर्ट आहे, incline आहे, इथे चेंज काय येईल, हॉरिझॉन्टल रिएक्शन म्हणजेच Fy असेल आणि व्हर्टिकल रिएक्शन म्हणजे Fx असेल. आणि इथं आता काय रोलर सपोर्ट असा आहे, रोलर सपोर्ट असा आहे, त्यामुळं इथं आपल्याला Fx रिलीज करावं लागेल. We have to release the Fx. So I have changed already. You can see here release is Fx, not Fy for this case. Is it understood? Yes or no?
Done, sir.
Right. तर आता Fy च्या जागी Fx रिलीज करायचं, कारण सपोर्ट आपला हॉरिझॉन्टल लावलेला आहे, त्यामुळे रोलर सपोर्ट हॉरिझॉन्टल आहे, सो वी हॅव टू रिलीज द Fx. So you can see that I have changed the Fx and remaining is as it is. Now I will go to the load, as I already assigned the load 100 kilonewton and 50 kilonewton. You can see okay, 100 kilonewton and 50 kilonewton. Now next is command perform analysis, all okay, then run analysis. We'll check whether our result will match or not. Zero warning, zero error. Go to post processing mode, apply, okay. We'll check the reaction, so whether we'll got 450 and 300. We'll check 450, 450 and 300. Yes, correct. Horizontal reaction, you can see 450, one is plus, second is minus, because they must be equilibrium. एक तुमचा लेफ्टला चाललाय तर दुसरी रिएक्शन राईटला यावंच लागेल, otherwise it will not in equilibrium. So system must be in equilibrium. So at point F, 450 is towards right, at point A towards left, and vertical reaction is 300. Yes, we got the same. 449.999, that is 450. Fx horizontal, x 449. At top you can see negative sign, at bottom there is a positive sign. Okay, and y is 300. Yes, whether values are matching, support reaction, yes or no?
Right, sir.
Right. Now we'll see the deflection, or we'll see the forces in the member. So in the member EFE, it is a 450, ED 150, BE 250, AB 150, 150, 450, 250, 150. We'll check these values. Beam, maximum axial forces. So you can see so it is a 450. Whether it is matching? Yes. In member FE, it is a 450. You can see 450. Yes, red color. At the right, you can see black strip 450. Then it is 150. Yes. In this member, it is 150. Yes. In member ED, it is 150. Then we'll check vertical member EB, that is 250, and BC and AB. It is 150, correct? It is 0. Yes. In this member, it is 0. As you can see, 0. In BC, it is 0. 0, 250. Incline member. Yes, 300 into root 2, 424. Yes. Now we'll see the deflection. We'll see the deflection, whether it is 34.5 at point D. At point D, it is 34.5. So we'll see at point D, at this point, 34.5 mm will be the vertical deflection. We'll see that displacement. Yes. Whether it is matching, vertical deflection 34.40. Is it visible? Black strip at the top right side window. So node 3, 34.40, 34.5, 40 and 34.5. Okay, is it match? Yes or no?
Yes, sir.
Right. Now see the deflection of the truss. Now, as you can see, cantilever end, which is to the left side, which is not deflected from its original position. जसं आपण भिंतीला एखादा हँगर वगैरे लावतो ना, त्या टाइप मध्ये हा ट्रस असेल. लेफ्ट हँड इज कम्प्लिटली फिक्स, लेफ्ट हँड इज कम्प्लिटली फिक्स and other is free, that is cantilever. Now you can see the deflection. Whether it is okay, understood, yes or no? Is
Yes,
it
sir.
okay? Right. Now you can see the animation of the displacement, how it will be deflect. Left hand you can see that where supports are there, left hand you can see whether where supports are there, they are not deflecting. Okay, that is fixed end, right? And the other is free end. As I told hanger example, okay, so that will be bend. Okay, similar way it is deflected at the free end. So like this is the deflection or the displacement of the your cantilever truss. Is it understood? Right. So now this is the deflection. As you can see, you can see the deflection 34.4 mm as per the Staad value. 34.4 mm. Vertical deflection, horizontal deflection, you can see. Right? So you can generate the report also. Okay. Click on the report. So I will click input all. So okay. Then this report is created in the Staad Pro. You can see whatever I have put up here, all it is printed at default. Section properties, material, support, load cases, etc. Then you can see the nodal load also. Okay, this is the input are there, right? So you can see all there, it is there, right? Steel design is also there, but we will not doing the design. Okay. So after the design, it will give the design result also. Okay. So click on the report. The report will be generated. Report will be generated. Okay. After the design, you get the value of the member properties. Means what type of section you are provided. That also you can see in the report. Okay, so click on the report, you can generate the report. All it is mentioned, job title, client, whatever you are giving the input, all it is printed default here. Date, time, etc. All. Whatever the input you are put up is also displayed here. Right? Is it understood?
Done, sir.
Right. So now next problem we will take. This one, same. Okay. We'll take this one. Now there is again same case, but this is a triangular truss. At free end there is a point load, and what it is mentioned, cross sectional area of member CD and DE. CD and DE. CD and D means this member having area is 2500, and those of other members, remaining member is having area is 1250. 1250. Okay. So first of all we will draw the truss. So whether the dimensions are given, okay, it is vertical is 2 meter and AC is 2 into root 3. 2 into root 3. 1 minute. How much it is, I will find out. 1.866 into 2. 2 into root 3. Yeah, 3.46. 3.46 is AC. AC is 3.46. Vertical is 2. Vertical is 2. AE is 2. AC is 3.46. 3.46. So what will be the EC value? So that is the right angle hypotenuse. So 3.46 square plus 2 square root of 15.97. It is 4 meter. CE is 4 meter. AC is 3.46. Okay, so I will draw the truss. Click on truss. 2808-2021. Truss 9 meter kilonewton. Okay, I will go to the open structure wizard. We'll see whether model is available or not. Triangular truss. No. Whatever the model we require, it is not available in the structure wizard. So we'll go to the add beam option. New project, truss 28/8/2021, plus 9 meter kilonewton. Yes, we will replace that file. We add beam option, finish it. So how much will be the height? 2 meter. So from 2 meter it is 3.46. 3.46, 1.3, 1 minute. 3.46 means 3.46 divided by 3. Divided by 3. So 1.15 meter. 1.1533. Okay. That will be okay. So 3.46. Incline is 4. Yes. So whether right, and then vertical is your 3.46 divided by 2. 1.73. 1.73 is AB. AB is 1.73. And 1.73. So this is the truss. Whether we'll got the same geometry. Yes. Yeah. Close it. Right. We'll got the geometry. So if you click this diameter length, it is 1.73 and 3.46. You can see here. Okay. 3.46. And whether we'll got this 4 meter. Yes, 1.992 meter. And again it is 1.99, that is 2 meter. 4 meter. So your 2 meter. And total is your 3.46. 1.73, 1.73, 3.46. Yes, we got the geometry. Right? Is it understood or shall I repeat?
Understood, sir.
Right. How many students are there? Okay. Till then students are sending me request. Okay. So now as we have created the model, So now material we will assign the property, also we will assign material and the property. So for assigning the property, area is your 2500 for CD and ED, that is this incline member 2500, and for remaining member 1250. So I will click on general, material, steel, assign to view, assign, yes. Then I will go to the material section database. Again I will choose the Indian angle. So first of all, 1250, 1250, 12.5, 12.5, and 25, 12.5 and 25, 12.5 and 25. Let's see whether it is available or not. 12 is available, 12.20 is available, 13.8, 11.4, yeah, 12.60 is available. So I will click on this, select this number, add. Now next is 2500, 2500, that is 25 centimeters square. 25, yes, it is available. 25.10, select this, select, add, close. So I will assign this section to this two number only, that is 2500 assign, and for remaining I will assign the 1250. Press control and select member and then assign. Yes, the properties are assigned as per the given case. 1250 is for all the members except these two inclined members, that is R2 is there. R2 is nothing but reference to having a raised 2500 mm square. Now next we will assign the support. How will be the support? So at the top hinge and at bottom roller. Again we will release effects. So create, pin, add, create, fix button. So where should I will click? In all checkbox or except which box?
FX.
Effects, right? So I will assign the hinge support to this end. Assign, yes. Then for this support, assign, yes. So the material is assigned, material properties are also assigned, support also assigned. Now the load. So there is only one load, that is 40 kilonewton load, and we have to find out the deflection, vertical and horizontal deflection at point C only, where load is applied. At this particular point, we have to find out the vertical deflection and horizontal deflection. So there is only one load, that is 40 kilonewton load. So click on loading, load case details, add, apply load, add, close it. Only one nodal load is there. Nodal load minus 40, minus 40, add, close. So node cursor will be activated. 40, apply to this node only, assign, assign. Shift V, you get the value, Shift V. Right, then now command, perform analysis all, okay. Next run analysis, save. Okay, now see the node reaction. So reactions are 69.18 and 40. We'll check. Yes, 40 is there, VA is 40 is there, which is with us, that is 40. Why? 40 is there, and horizontal is one is positive, second is negative, 69.19. So it is a 40 root 3. We'll check 40 root 3 how much it will be. 40 root 3. 40 root 3. Yes, it is 69.28. 40 root 3, 69.28. Yes, 69.20. That is matching. Now next we will check the forces in member, maximum forces. So this member having values your 69.19. We'll check. It is 40 root 3, same. Then 40, 80. Incline member ED. ED is 80 kilonewton. We'll check that. Yes, it is 80. Yes, 79.92, that is 80. In this member it is 80. In this member it is also 80, right? Then BD and AD, we'll check whether this will got 0. Yes, it will got 0. You can see there is a 0, and this also carries the 0 force. These two members carry the 0 force. Yes, the forces in members are also matching. Forces in the member are also matching. And we'll check now the deflection. So vertical deflection is 3.26 and horizontal deflection is 0.96. 3.26 and 0.96 at free end. So click on node displacement at this end. Yes, correct. Minus 3.23 and 0.95. Vertical deflection we got 3.23, 3.23, and horizontal deflection is 0.95. So yes, 3.23, that is 3.26, which are exactly matched. 3.23, 3.26, and vertical deflection 0.95. We get 0.95. In calculation it is 0.96. So it is exactly matching these values, 0.95 and 0.95 and 3.23. Is it understood, all of you? Is it understood? Now see the deflection. See the deflection of the truss. See the deflection of the truss. Left hand you can see. So now at the roller support, that is deflected in vertical direction. For this truss, at roller support, it will deflect in the downward direction only. Is it understood, all of you? Is it understood? Is it understood, all of you?
Yes, sir.
Right.
Done,
So
sir.
now next, okay, thank you. Now next problem. Now we'll solve this. Then we will find out only the forces in the member. You can see the table is there. As you are studying in, as already you are studied in your first year mechanics, this type of process. आता मी किती न्यूमेरिकल घेतले तरी तेच प्रोसिजर असणार, फक्त मॉडेल नवीन आहे आणि एरिया आपण अप्लाय करतोय. आता इथे हा मेकॅनिक्सचा न्यूमेरिकल आहे. हा जो दिसतोय स्क्रीनवरती अप्लाइड मेकॅनिक्स किंवा इंजिनिअरिंग मेकॅनिक्स न्यूमेरिकल आहे. जिथं कॅन्टिलिव्हर ट्रस आहे, फ्री एंडला पॉइंट लोड पी आहे. तिथं आपण काहीतरी व्हॅल्यू घेऊया, त्याप्रमाणे त्याच्या मल्टिप्लिकेशन मध्ये तुम्हाला बाकीची व्हॅल्यू भेटेल. पी ची व्हॅल्यू जे भेटेल, पी ची व्हॅल्यू समजा 10 किलोन्यूटन घेतला तर इथे टेबल मध्ये तुम्हाला 2p म्हणजे 20 येईल, p म्हणजे 10 येईल, बाकीचं 2.3 येईल, इंटू 10 म्हणजे 22.36 येईल, 2p म्हणजे 20 येईल, 2.36 म्हणजे into 10 gives us the 22.36. If we take the p is equal to 10, if we take, okay, so we'll solve this truss. अडचण आहे का आतापर्यंत ट्रस मध्ये असेल तर विचारा, तर मी किती मॉडेल घेतले तरी प्रोसिजर तर तेच असणार आहे. स्ट्रक्चर विजार्ड पण दाखवलं तुम्हाला आणि ऍड बीम ऑप्शन पण केला, आपण दोन्ही केला. ओके, आता ट्रस कसा आहे, असा आहे. तर हा ट्रस तर स्ट्रक्चर विजार्ड मध्ये येणार नाही, तर आपल्याला ड्रॉ करावं लागेल. तर डायमेन्शन 10 मीटर 10 मीटर म्हणजे हॉरिझॉन्टल डायमेन्शन टोटल 20 आहे, वर्टिकल 10 आहे. ओके, सो आय विल क्लिक ऑन द ऍड बीम ओनली, फिनिश इट. Edit. is required and 5 meter is okay. 5 plus 5, no? 5 plus 5, 10 vertical, horizontal 20. Okay. So how we will draw the truss? from base it is 5, then vertical 5, then connect like that. Okay, first of all we will draw the base 5 meter. Then 5 reverse, then vertical 5. Then after that this is created, then incline. We'll connect this line. Okay. And then this over. Then directly at 10 and vertical. There is no vertical line. Huh? Okay, the ED is not member. ED is not the member, right? ED is not the member, right? So this is the truss, right? ED is not the member, remember. For this truss, ED is not the member. ED, it is E at the fixed end, D is also fixed end, that is cantilever truss. So we'll assign the fixed support, right? But as I told, from the free end, if you're doing the manual calculation, जब तुम manual calculation करत असाल, so always start from free end. In case of cantilever truss, always start from free end. That is from the free end, you can start taking the summation of x, summation of y, by using method of joint or method of section. Okay, you can get the forces in the member, right? Now I will assign the property. Now model is created. Material, steel, assign to view, assign, right? Then property, as you can decide the property now, because there is no area is given, we are solving the simple numerical. Angle, you can take any section, it will not affect on the force, internal forces member. Assign to view, assign, yes. Then assign the support, we'll assign the fixed support. Okay. Then point load is applied at this end, P. So we'll take the nodal load. Suppose we will take minus 10, add close. So it is P. I will replace P as a 10 kilonewton. So we'll check whether the answers are matching or not. Shift V. And then command, perform analysis, all. Okay. We'll check whether we got the result or not. Beam, forces in member. Yes, you can see 10 in bottom member. dB, dB. Okay. This 10, then next is 14.142. Will not get the result exact because it is in terms of P. Okay, but like this you can find out the force in the member. It is 10, 10, 14.43. Okay, so like that we have to analyze the truss. That is simple truss I have taken, right? Yeah. Now this is the most important thing, that is incline load. How to assign the incline load on the truss. That is the last part that we will discuss in case of truss, right? How we have to apply the incline load on the truss, that we will see now. Click on new truss 2808-2021 plus 10 meter kilonewton. Next, okay. So add beam option again, finish. So dimensions we will find out. This incline is 2 meter, 2 meter, and base is not given, so that is the 90 degree. If you take this 90 degree, 2 meter, 30. So how much it will be? AC theta will check. Hypotenuse, adjacent side. Cos theta is equal to adjacent side 2 meter by hypotenuse. So 2 into cos 30. 2 into cos 30. So 1.73. 1.73 will be AC. 1.73 will be AC, right? 2 into cos 30. 1.73 AC. Then BC is equal to how much? 2 into sine of 30. 2 into sine of 30. It is 1 meter. So BC is 1 meter. So D will get 2 meter. Sure. D is get 2 meter. DE 2 meter. AC is 1.73. So EC will be same 1.73. Right? So we got the value. So it is 2 meter, 2 meter, 1.73, 1.73. It will be 3.46, I think. 1.73 multiplied by 2, 3.46 is the AE. AE value is 3.46. BC is 1 meter, DE is 2 meter. Okay, we'll draw the truss. So total is required 3.46 sufficient. Okay. Edit 1.73. Vertical is okay, 1 meter. So 1.73, 1.73. Okay. Escape. Then incline. This is a 2 meter. This is your 2 meter. So C will be, sorry, point B will be at a distance of, again I will draw the perpendicular from this. So I will get the ordinate of the point B. Point B चा ordinate काय येईल? तिथून जर ordinate vertically drop केला तर height is your 1 meter. Okay. And this will be 1.73. Right angle triangle. परत हा जर बेस घेतला, हा 90 डिग्री झाला, हायपोटेनस बी AB हायपोटेनस झाला, तर 2 मीटर हायपोटेनस. Then cos 30 is equal to adjacent side, that is this horizontal, hypotenuse 2 into cos 30. 1 minute. Sin 30 is equal to opposite by hypotenuse. So it is 2 into sin 30. First of all, we have to find out the values, then and then only we will draw the truss. So vertical is 1. Hypotenuse cos 30 adjacent AC 2 meter divided by hypotenuse. So 1 minute. Can anyone find out the value? First of all, I will find out the value, then and then only we will create the model. Wait, I am calculating the value. 2 meter is the hypotenuse, sorry, adjacent side is 30. So BAC, so hypotenuse cos 30, 2 meter by hypotenuse AC. So AC is equal to 2 by cos 30. So 2 by cos 30 divided by cos 30, 2.30. AC will be 2.30. AC. Similarly, EC. EC is 2.30. So total will be 4.6. Okay. Then again I will draw the perpendicular. So hypotenuse will be this hypotenuse. So now this will be cos 30 is equal to adjacent is suppose AC dash by adjacent by hypotenuse AB. AB is 2 into cos 30. That is AC dash 2 into cos 30. 2 into cos 30. It will be 1.73. So this will be 1.73 and vertical will be 1 meter. So ordinate of B is your 1.73. No. Similarly for this case, 1 minute. Then if I will take the triangle BDC. So I will draw the triangle, 1 minute. So it will be 2.30. Okay. So it is 2.3, 2.3, 4.6. Okay. Then this ordinate will be 1.73 horizontal. Vertical is 1. Okay. Again edit 1.73. I will create this direct. So I will add this movie. X will be 2.3 plus 2.6, 2.1.6, 2.9. 2 by sine 30. Meter. 1.15. One minute, huh? Yes. Okay. So model is created. Then connect this incline member. Right. So is it okay? So first of all, we have to find out the values, because as you know, in case of AutoCAD also you have to find out the ordinate. You can find out the ordinate, right? Then you have to draw the model in the truss. Similarly, for the in case of Staad Pro, first of all we have to find out the values, because in the this truss angle is given. Okay, and the BD and AB values are given. So from that we have to find out AC, EC, ED, BC values. Then we have to find out the ordinate of each and every point B, D, EC, etc. Okay. So from that you can create the model. So as model is created, then left support is your hinge, right is roller, right? Left is hinge, right is roller. Remaining we will assign. So first of all, material, steel, assign to view, assign, yes, property, as section database. So whatever the section you want, you can assign angle section, because we will find out only the forces in member. So add, close, assign to view, assign, yes. The next is your hinge and right is roller support. So support, create, pin, add, create, fixed butt, except FY, all must click. Then click on this left support, assign to view, assign, and then for right, assign to view, assign. Now material properties are assigned. Now next part is loading. So 20 kilonewton load is applied incline, right? 20 kilonewton load is applied incline. So on each model, so on each point. So I will break this beam. So 40. So now these are the two beams. Now what we have to check here, we have to see the dimension, that is 1.75. This dimension you must write down, because if you apply the inclined load, so the correct dimension you must know. So 1.9406, that is the length is there. Okay, 1.74906, right? So what I am doing now, I am applying the inclined load, so that's why the dimension must be known to all of you. So the inclined load, add, close it. So now I am double click on this. I require this value, that is length is equal to 1.74906, right? I require this value applying the inclined load. So now click on this inclined load, add member load, concentrated force. So it is a 20 minus 20, and you must change the direction now. Now as we default, we are applying global y direction, but now I will change the global y direction to the local y axis. So D1 is your suppose 1.74906 and D2 is your 0. So I will add this, and now I will change the dimension D1 and D2 will 0. Again y local, add, close it. Okay. So if I will select this, assign, you can see here how the load is applied. Incline, shift V. Is it understood or shall I repeat? Is it understood or shall I repeat?
Repeat, sir, please.
Yes, please.
Sir, explain once again.
Okay. What I have to explain, load or other thing? Can I explain?
Sir, y local direction.
Yeah. So what I have changed, you can see here. So y local, कारण काय होतं, ग्लोबल y म्हणलं की तो फक्त वर्टिकल डायरेक्शननेच होईल, एक्झॅक्टली वर्टिकल, डाऊनवर्ड किंवा अपवर्ड. आता y लोकल काय, y डायरेक्शनने तुम्ही फोर्स अप्लाय करू शकता, इन्क्लाइन किंवा डाऊनवर्ड, अपवर्ड. आता मायनस व्हॅल्यू पुटअप केल्यामुळे तो डाऊनवर्ड होईल. जर मी प्लस केलं, जर समजा मी प्लस केलं, okay, I will make plus, then you can see the change. I will change it. You can see it is applied like this. So given is minus 20, so change like this. So हे लक्षात ठेवा, ज्या वेळेस तुमचा फोर्स एखादा इन्क्लाइन असेल ट्रस वरती किंवा कुठल्याही स्ट्रक्चर मेंबर वरती, बीम वरती किंवा फ्रेम वरती किंवा कॉलम वरती इन्क्लाइन लोड असेल किंवा बिल्डिंग वरती इन्क्लाइन लोड असेल, त्या केस मध्ये तुम्हाला ग्लोबल एक्स वाय झेड घेता येणार नाही ग्लोबल एक्स वाय झेड. त्या केस मध्ये तुम्हाला लोकल ऍक्सिस घ्यावं लागेल, म्हणजे तुम्ही ऍक्सिस डिसाइड करता येते अदर दॅन ग्लोबल तर वर्टिकलच आहे, वाय इज वर्टिकल. आता इथं वाय लोकल करतोय म्हणजे आपण त्याला इन्क्लाइड फोर्स अप्लाय करतोय, आणि त्यासाठी हे D1 आणि D2 चे डिस्टन्स तुम्हाला इथं पुटअप करणं गरजेचं आहे, अदरवाइज यू विल नॉट अप्लाय द पॉइंट एक्झॅक्टली ऍट द नोड. त्यामुळे ती लेंथ तुम्हाला त्या मेंबरची इथे कन्सिडर करावं लागेल. इज इट अंडरस्टूड?
Done, sir.
Right. Now I will check this. You can see here. Now next load is applied. This is second, this is first, and if I apply this load, you can see, right? So 20 kilonewton, 20 kilonewton, 20 kilonewton. Is it okay? लक्षात आलं? काय केलं, एक दुसरा लोड घेतला मी, 0 घेतला D1 आणि D2 1.74 घेतला, आणि पहिल्याला D1 is 1.74, then D2 0. So like that I will apply the load. So this, like this you can apply the load. Only main thing is that change the direction, that is Y local. Change the direction, that is Y local. Is it understood, all of you?
Yes, sir.
Then I will go to the analysis, perform analysis. Okay, we'll see whether results are matching or not. As we have somewhat changed the dimensions, or whether dimensions are correct or not, we don't know. We'll see the result and then we'll check. Beam axial forces. So it is 14.57. We'll see this, whether we'll got the same value. 14.57. Okay, that is near about 15. Yes, 15 kilonewton. 14.57 or 15, that will nearly match, exactly match. Okay, that is 0.43 difference. Then next is your 2.93. It may be changed. It may be changed. Yes, it is 5. As I told initially also, as we are somewhat changed the dimension, it is 30.165. We'll check. 30 is correct, matching. 30 is matching. Okay, ED is 30 and we got same 30.16. Then it is 15.4. It is 17.32. Okay, some values are matching, some values are not matching. It is 15.82. It is 20. Maybe due to the dimensions are changed. Okay, due to that the values are somewhat different. Then it is 17.5. 17.32. That is matching. 17.32 is matching. 20. Yes, this member is 20. This is correct. 20. काही फोर्सेस मॅच होत आहेत, काही फोर्सेस मॅच होत नाहीत. 2-3 मेंबर सोडले तर बाकीचे आन्सर्स एक्झॅक्टली मॅच होत आहेत. ओके, सो इज इट अंडरस्टूड हाऊ द इन्क्लाइन लोड इज अप्लाय. इतर महत्वाचं काय, तुम्हाला इन्क्लाइन लोड कसा अप्लाय करायचं ते महत्वाचं आहे. व्हॅल्यूज मे बी मॅच, काही आन्सर मॅच झालेत आपले, काही नाहीये. 1-2 मेंबर सोडले तर बाकीचे आन्सर्स मॅच झालेत. तर मेन थिंग काय, तुम्हाला मी न्यूमेरिकल का घेतलं हे, तर हे इन्क्लाइन लोड कसा अप्लाय करायचं त्यासाठी न्यूमेरिकल घेतलं. ओके, सो 20 किलोमीटर 20 किलोमीटर 20. ओके, आन्सर्स मॅच होत आहेत 1-2 मेंबर सोडले तर. राईट, इज इट अंडरस्टूड ऑल ऑफ यू? काही डाऊट आहे याच्यामध्ये कुणाला असेल तर विचारा. आय विल रिपीट वन्स अगेन. Yes, please. Any doubt?